Hi, good to see well, good to have you all here. I'm going to be going through activity 1 and a bit of activity 2 today. So just follow along if you'd like or continue to work through it. But I'm going to start with this first one here. So as we're working, this says that we're going to write the equation of a circle with center at the origin and a radius of 8 units. So just as a reminder over here, I'm going to go ahead and draw out what or write out our equation of a circle. So we have x minus h squared plus y minus k squared equals the radius squared, or r squared. Now, just as a reminder, hk, that is our center. And those are going to be opposite signs than what you see in your center. And r is our radius. Okay, so for over here, our center's at the origin, which means that we're at the point 0, 0. And so if I plugged everything in as is, I'd get x minus 0 squared plus y minus 0 squared equals 8 squared. Now you could leave it like this, or we know that 0, if I add or subtract that from anything, doesn't change it. So I would actually just be left with x squared plus y squared. And then I know what 8 squared is, that's 64. So you could just keep this part right here. That is our answer. Okay. Now as we continue going, these are going to change a bit. We're going to have different centers. Some of them will give us a diameter. If you want to pause here, go ahead and try those. Go for it. And then I will be starting these up. Or if you're trying to check your work, feel free to skip ahead to the ones you're trying to look at, or you can go look at the key. So let's go on to this next one with center at 3, 5 and a radius of 6. So one way I remember how to write this is I know it's always x minus the x value in my center. In this case, it's 3. Don't forget the squared, because it's Pythagorean theorem, plus y minus the y value in our center, squared, equals our radius squared. In this case, our radius is 6. 6 squared is 36. Okay. So it's pretty straightforward, kind of going through it. And remember, I got that 6 or 36 because 6 squared, there we go, equals 36. So this is where I'm getting that 36 from, because I know I'm going to be squaring that radius for my equation. The next one is a little bit different because instead of the radius, I'm given the diameter. So I know that the diameter is always going to be 2 of our radii. So if I take 4 and then I divide it by 2, that will give me a radius of 2. My point, or my center, is -2, 6. So if I write this out, I'll get x minus -2 squared. You can leave it like that. Or we know that if we subtract a negative, that turns into a positive. So I would accept either minus a negative or a positive 2. And then plus y minus the y value of our center, which is 6, squared equals, our radius here is 2. 2 squared is 4. So in this case, it is the same thing as our diameter, but it's not always going to be. That only happens if our radius is 2. Now, this next one also uses the diameter. But now our diameter is the square root of 13. So I'm going to be doing a little extra work here. I'm going to actually zoom in just a little bit that I can write a little bit better and kind of move us over. Okay, so for this one, we have a little extra going on. We have this diameter of 13, which means that for my radius, it might help if I write this in pen and a highlighter. For our radius, we're going to take the square root of 13 and divide it by 2. Now this just is our radius. I want to keep everything exact, so I'm not going to plug this into my calculator. I'm just going to write it like this. Now if I want to know what my radius squared is, if I take square root of 13, because this is what's going to go into my equation, if I square this, I'll get square root 13 squared, which is just 13. These are inverses of each other. And then I'm also going to square the 2, so that will be a 4. This is what's going to go into my equation. Okay, that's what's going to go into the equation. This is my radius. This is that radius squared. So as I look here, I have a 0 for my x in my center. So I'm going to have x squared, because I know if I subtract 0, I will not change anything. Plus, then I get a different number. So I have y minus a -9. And again, we can change that to be a positive, because subtracting a negative is the same thing as adding. Squared equals, and we already know what square root 13 over 2 squared is, so we can just put that as 13 over 4. Okay. For the next one here, I'm going to keep going down, maybe possibly. There we go. For the next one, I have a center at the origin. Anytime you see center at the origin, we're just going to have x squared plus y squared. Okay. And then I have a point that passes through 0, 7. So this isn't telling me the radius, but I can figure out that radius. I'm going to use this dot here as my center. Actually, I'm not going to use that dot as my center. I'll draw in a new center. So if this is my circle, here's my axes, my y and my x. And this is saying that we have a point 0, 7. That is right here. That means that my radius is 7 units, because I'm going from 0, 0 to 7, or 0, 7. And now I have that radius of 7. So for my equation, I need that radius to be squared. So 7 squared is 49. All right, and then we have one more down here. This one will take a little bit more. Luckily, you will have a bit more room than I have. So we now have a center at the origin. Again, that will just be x minus 0, or x squared, plus y minus 0 squared, or just y squared. And now I have that it passes through this point of -5, 12. So again, if I draw that out, let's say I drew this out. We'll pretend like that was a nice straight line there. All right, and now I have my circle at the origin, and I have 12, -5. This distance I can find using Pythagorean theorem. My x value is 12, that's my distance here, and I have a vertical difference of 5. So this is a nice right triangle here. I'm going to have to use my Pythagorean theorem. I'm going to go ahead and erase some things here, just that way I have a little bit more room. There we go. All right, so I'm going to go ahead and plug this into my Pythagorean theorem, or you can use the distance formula with 0, 0, and 12, -5. I know anytime I'm using the Pythagorean theorem to find a distance between 2 points, I'll be using and finding my hypotenuse. So I'm going to have maybe 5 squared plus 12 squared equals c squared. 5 squared is 25. 12 squared is 144 equals c squared. And that will be 169. I almost put 96 there. 169 equals c squared. And if I take the square root of this, I will get the number 13. So in this case, my radius is 13 units. If I take the radius squared, that will be 169. So again, this right here is my radius, right? Radius. So whenever I plug that into my equation, I always square it. That's how I get that 169. Okay, so these are all going from characteristics. Maybe you had to draw out the parts here. And now we're going to move on to page 11. I'm only going to go through 2 questions on page 11, so feel free to look through those. But I'm going to go ahead and start going through these with us. Okay, I'm only going to go through questions C and D. For question C, we have to first figure out where our center is. The center of this circle is at the point -2, +2. Make sure you're always putting your x value first, your y value second. In this case, if I have a grid like this, then we can easily find the radius by starting at our center and either counting up or down or left or right. I'm going to count to the left here and stop whenever I hit my circle. So I have 1, 2, 3 units. That is my radius. So that means my radius is 3 units. Now as I start writing this equation, I know I'm always going to have x minus the x value, which is a -2. Anytime you see a negative, you can change that minus to a plus. We've talked about how subtracting a negative is just the same thing as adding. So we get x plus 2 quantity squared plus y minus the y value, and this is that +2. Notice you're always going to change signs from the center of your circle to the equation where you see the centers there. Don't forget the squareds. And then I also need my radius squared. My radius is 3. 3 squared is 9. And there is this problem right here. Okay. Now, one more to go through for this video. Oops. Might help if I can actually get moved over. All right. So now for D. This one no longer has a grid, and we have a point 0, 0, and a point 4, 5. So we have that point at the origin again, so I know that my center is at 0, 0. Now I need to find that radius. In order to find that, again, we're going to have to use that Pythagorean theorem. Okay. I know that my horizontal difference, that's my difference in my x's from 0 to 4, that's 4 units. This distance from 0 to 5 is 5 units. So now I'm going to go ahead and we're going to find this radius by taking 4 squared plus 5 squared equals our radius squared. And notice here I'm actually going to put radius instead of just c because we know this is our radius. So now I have 4 squared plus 5 squared, so that's going to be 16 plus 25 equals our radius squared. If I start adding all of these together, let's see what we get. Don't have that right off the top of my head today. All right, it's going to be 41. And 41, this is going to equal our radius squared. Now, this is kind of nice anytime you're solving for this because radius squared is in our equation. Let's go ahead and figure out what that radius would be just itself. So this radius would be the square root of 41. This is not only not a perfect square, but is also a prime number. So we're just going to leave that as square root 41 for our radius, keeping that exact. But we also know we have our r squared, so we know what we're going to be putting into the equation. We can kind of use that to make our lives a little easier. So we have center at 0, 0. X minus 0 squared is the same thing as x squared. Y minus 0 squared is the same thing as y squared. And this will equal r squared, which is just 41. All right. And that is all I have for you. Continue working through these. Remember, you have a key on Google Classroom and also up around the room. I think there's one in the Spartan Center, or just others with the subs. Make sure you ask. But have a fantastic day. Have a fantastic weekend. And I will see you all later. Bye.